Hello friends, welcome to this channel. This is G Solutions, where we find solutions for your needs. Today we will have the voltage waveforms of the two alternating current sources. Suppose you have a voltage B sub AB, and the value of this one, simply as general representation, that will be the maximum value of the voltage AB multiplied to sine omega t plus phi. Okay. So this B sub AB actually can be represented by a graphical representation of the sinusoidal waveform like this one. So we have here a y and x plane. This is the x-axis and the y-axis, and this is the origin. And your waveform will be like this one. Okay, so your phi will be this part. This is your phi. Okay, that is the place or the angle where your waveform started and hit the x-axis up to the origin. So that is the phi. So positive angle means that will be the angle before the origin. Okay, and by the way, our schematic representation in a circuit is like this one. So this is your A and this is your B. Okay, so this is B sub AB. And B sub AB is not equal to B sub BA. So always remember that it can never be equal. So you must look at the points. BA, this is BA, this is AB. But if you want to get the value of B sub AB and make it equal to B sub BA, so B sub BA, getting the value of B sub AB, we introduce a negative sign. So this is positive, so we make it negative. So that will be B sub M AB sine omega t plus phi. Okay, or if you are going to remove negative here, B sub M, or the peak voltage value of B sub BA, you have to use again B sub MAB. So what we should do is we should just introduce an angle for which is for our sine function, so plus phi. So the angle opposite directly on the other side of your voltage is 180 degree. So you just add here 180 degree, and this makes this positive B sub MAB. Okay, so this is also B sub BA. Okay, so now the other value, let's have another source which is B sub CD. Okay, again, general representation is the maximum value of the voltage at point C and D sine again omega t, but at this point let's have the negative beta or negative angle. So what will be the schematic drawing of this, the graphical representation in XY plane? So actually this is like this one. So okay, it's like that. So the angle beta is here. Okay, that is the angle after the origin and to the place where your curve hit the x-axis. That will be the beta. So negative beta, always remember that it is after the origin. Okay, so again we use the schematic circuit diagram. Let's say this is C and D, this is B sub CD. Okay, and again B sub CD is not equal to B sub DC. So to be able for us to make it equal B sub DC using the value of B sub CD, okay, so we introduce negative at before the maximum value CD sine negative omega t minus beta. Now if you want to remove negative here and make it positive, so B sub DC is positive B sub M CD sine again omega t minus beta, and let us introduce 180 degree. Okay, so therefore since that we have this schematic diagram for B sub AB, okay, this is AB and another one here, let's say this is D and C. So we have two voltage sources. We can connect it in two different ways. The first one is when you connect point C and B. So therefore you have now the outermost part of these two connected voltages is AD. So this will be your terminal B sub AD, and this can be considered as our terminal 1 for the first way we can connect these sources. So therefore we have to add B sub AB, the value of AB going starting from A, and then we go to B, and then we go from C to D plus C to D. Okay, so this is B sub AD. So again let me just draw a schematic symbol for the AC source. This is again D and this is C. We can connect it here, B and D. So the outermost part of our circuit where we connect these two sources is B sub A and B sub C. So we can say that this is B terminal 2. This is the second way of connecting these two sources. So in this way we have the value for B sub AB added to the value of B sub DC. Okay, so in this case here for the first way of connecting the sources B sub AB, we have here a value. We just have this equation and add to B sub CD. B sub CD is this one. Okay, and for B sub AC, okay, or the terminal 2, that is B sub AB, again this value B sub MAB sine omega t plus phi plus B sub DC, and B sub DC is this one, negative B sub MCD sine omega t minus beta. Okay, so that's how you connect two sources. Now, your source can be also in RMS value or in phasor form. Our B sub AB, we can convert this into phasor form. And in phasor form, we are using the RMS value. So, what is our maximum value for B sub AB? That is B sub M AB. Now, to make this as an RMS value, so we divide this by square root of 2. Okay? So, the angle is phi. So, we will use this angle. So, therefore, we can, instead of writing this one, we say RMS, okay, for AB, C's of phi. And for B sub CD, again, the maximum value of C and D divided by square root of 2, C's of negative beta, or the RMS value of C and D, C's of negative beta. Okay? So, therefore, we can also represent this source into a schematic diagram for our circuit. We can have this like this one. Okay? Where this is our A and this is our B. And B RMS. Instead of writing the full RMS, I just write R. Okay, and AB, C's of phi. Okay, so my polarity is here, positive, negative, and also I can write B sub C, CD. Okay, like this one. Okay, this is CD and this is BRMS, CD, C's of negative beta. Okay, this is where my polarity is placed. Okay, so this is all about the sum of the voltage of two voltages in our alternating current source. Okay, so thank you for watching this video. I hope I have added additional information to your learning desire. Thank you so much.